Hi, welcome to my video on the average rate of change for a quadratic function number 2. Let's do further explanation on the average rate of change for a quadratic function. And again, remember, it's the average rate of change is the slope of a secant line that cuts the parabola at 2 points. Find the average rate of change in the area of a circle when the radius changes from 2 centimeters to 5 centimeters. Express your answer in terms of pi. Well, remember, the average rate of change is your slope. And so the area of a circle, area is defined as pi r squared. So what we have to do is we take the radius, we want the average rate of change from 2 to 5. So at 2, the area is pi, with r is 2 being squared, so that's 4 pi. Remember, this is centimeters here, so this is square centimeters. And when the radius is 5, I'm going to put 4 there then. Radius is 5, so the area is pi, and the radius is 5 squared, so that's 25 pi. And again, it's centimeters squared. So the average, so this point right here is when the radius is 2, then the area is 4 pi. When the radius is 5, the area is 25 pi. So the average rate of change is your slope. So the slope, or let's say slope, same as the average rate of change, is y2 minus y1 all over x2 minus x1. So that's 21 pi over 3. So the average rate of change is 7 pi. And it's 7 pi. That's 7 times, you want a decimal, 7 times 3.14, you give a decimal for it. And that's centimeters squared. That's the area in relation to the length of the radius, which is centimeter. Now, it's awkward to do this because you got centimeters squared divided by centimeters. Most people would cancel those out. But by not canceling, what you see is that the area, square centimeters, and this is the radius in centimeters, cm. So that's the average rate of change. Now let's look at another problem to explain the average rate of change. The perimeter of a rectangle is 20 centimeters. Express the area A as a function of the width. Well, we have a rectangle, let's draw a rectangle, and it says the perimeter of a rectangle is 20. So a rectangle got a width, length, and length. So the perimeter of a rectangle is P equals 2L plus 2W, because there's 2 lengths and 2 widths. So the perimeter we have is 20. So 20 equals 2L plus 2W. So we can, let's change that around. I'd like to have it on this side. And we want to find the area as a function of the width. Right now I got length and width. So if I write down area is length times width. Right now, the area is a function of length and width. In order to get the area, I need the length and the width in this equation. But if I want the area as a function of the width, that means the L has to be changed as a function of the width. So solving this for L, so dividing by 2, I get L plus W is 10. And that means L is equal to negative W plus 10. Now I have the length in terms of the width. So if I take this equation here and change the length to negative W plus 10 times the width, so here the length is a function of the width. So if you take the width, if the width is 1, and the length is 9. If the width is 2, the length is 8. And so this fills that in there. So now, instead of having the length and the width, I have all widths. So if I multiply, I get a negative w squared plus 10w. Now the area is a function of the width. And again, this could be written as a with a w there, like that. Or you can have it, just leave it like that. So the area is a function of the width. What this means, because the parameter adds up to 20, then to get the area, I only need the width. Once I have the width, as long as the width and the length adds up to, the width and the length adds up to 10, this equation will be hold true. So notice the parameter is 20. So this equation is true for the area as a function of the width if the parameter is 20, not if it's 40 or 80 or 100 or any other number. So to illustrate that, this is the equation, which is a quadratic. So that means I could do more work on this later on, but I'm not. I'm just trying to show you that this is a parabola. So this equation here is like y equals ax squared plus bx plus c. So this equation is a parabola. It's a quadratic, like this. So to illustrate that, I made this SketchUp. So what happens is, if you take the width, we can't have the width 0, because if you make the width 0, then we don't have an area. We don't have a rectangle. So let's make the width 1. So if the width is 1, right here, if the width is 1, that means the length is 9. So 1 plus 9 is 10, and there's 2 of them, so it's 20. So it's, right? So what's the area? Area is length times width, 9. When the width is 2, they got to add up to 10. So that means if the width is 2, the length is 8. But the area is 16. If the width is 3, the length is 7, because they got to add up to give us 10. And the area is 21. And if it's 4, then I have a 6. Area, 24. Length times width. If you have a 5, then the length is, if the width is 5, the length is 5, because it has to add up to 10. Or if it adds up to 10, there's 2 of them, so it's 20 for the perimeter. And so the area is 25. So what about if we make the width 6? That means the length is 4, so we get a 24. So that's 7, this becomes 3, so that's 21. If this is 8, this is 2, so that becomes a 16. If that's a 9, and that's a 1, that becomes a 9. So notice right in the middle here. So let's graph this and you'll see that this is the highest point. So 1, so we're graphing, this is the width, and this is the area. Width and area. So when the width is 1, the area is 9. When the width is 1, the area is 9. When the width is 2, the area is 16. When the width is 2, the area is 16. Again, just take an approximation. When the width is 3, the area is 21. 21, right here. When the width is 4, the area is 24. Width is 4, the area is 24. When the width is 5, the area is 25. And width is 6, area is 24. 6, now you can see it's beginning to come down again. So, because this is a quadratic parabola shape, that each, as you can see, these numbers are symmetrical. The y values will be the same. So 7 is a 21. 7 is a 21. 8 is a 16. And 9 gives us a 9. So when the width, if you look at it, when the width is 0, the area is 0. When the width is 0, the area is 0. When the width is 10, if you put 10 in here, that's negative 100 times 100 is 0. So what we have this. But in order to have it, there's the parabola. But notice, we can't have this. When we think about it, if you had a word problem making up 20, we can't have 0 for the width. And we can't have an area. You can't have the width 10 because you get an area of 0. So notice your width goes from, your domain, which is your width, goes from 0 to 10. And the range, which is the area, goes from 0 up to 25. Okay, this is an illustration of how this is working here. I wanted to show you this. State each width. When is the area increasing? The area is increasing when the slope is positive. The slope is positive here, from here to here. So the area is increasing from when the width goes from 0 less than W less than 5. So when the width goes from 0 to 5, notice it's not equal to 0 or equal to 5. And it's maximum at W equals 5, which is the vertex. Notice the vertex here is 5, 25. So the vertex, when the width is 5, the area is 25. Because this is the area, this is X and this is Y. So the area is a function of W, so Y is a function of X. And it's decreasing on this side. So it's decreasing when the width is 5 less than or equal to W less than 10. So again, it's increasing on this side, decreasing on this side. Slope here is positive, up to the right. Slope here is negative, is down, going down to the right. State the average rate of change in the area when the width changes from 1 to 4. So 1, I want to make sure you can see this. 1 gives us an area of 9, and 4 gives us an area of 24. So let's convert the slope. The slope is 24 minus 9 over 4 minus 1, which is, if you look at that, that's a 15 over 3, so that's a 5. So from 1 to 4, the average rate of change is a 5. And from 1, which is right here, X is 1 right here, and X is 4 right here. So the slope of this line going through here, the slope of this line between these 2 points is a 5. Now what's the slope of the line between, what do I say? Between 5 and 9. Between 5 and 9, when X is 5, we have it here. When X is 9, we have it here. So we're looking at the slope of this secant right here. So 5 is a 25 in area. 5 is a 25, and 9 is a 9 gives us a 9. So what's the area? Rate of change? It's 9 minus 25 over 9 minus 5. So that's negative 16 over 4. So it's a negative 4. So the slope of this line is a negative 4. Hopefully that you can see how we're working this out. Again, it's increasing from 0 to 5, is decreasing from 5 to 10. And right here, it's not increasing or decreasing. It's what we say stop, or it's its maximum point or minimum point. Okay, let's look at another one. The more you do, hopefully the more you'll help you understand. f of x equals x squared minus 8x plus 18. And it says state the values of x where the average rate of change is increasing, not changing, decreasing. So to find that, we need to look for its vertex. And one way, we can say y equals x squared minus 8x plus 18. And one way to find its vertex, and I'll do it this way by completing the square. So a half of negative 8 is negative 4 squared is 16. So I put a 16 on here that's not here. So when I put a 16 on, I have to take it away to balance it out. So that means that we made this a perfect square trinomial. So this is factorable. And this is x squared, which is an x. A half of negative 8 is negative 4. So this is a perfect square trinomial, which is a binomial squared. Because I put 16 here, made this a perfect square trinomial, I can go x, and a half of that is negative 4 squared. And that binomial squared will give me this trinomial. And that 18 minus 16 is a plus 2. So if you squared this out and added 2, you'll come right back to here. That means that this parabola has a vertex of 4, 2. And let me draw that very quickly. It has the parabola, has a x is 4, and let's say y is 2 right here. And it's going up. Notice this is positive. Because it's positive, and I'm just doing that, I'm not really concerned where it's going. And I know there's the vertex right there. That point is 4, 2. And I know it's going up because it's positive. So that means it's increasing to the right of the x coordinate. So the x coordinate here is 4. So it's increasing when x is greater than 4. So when x is greater than 4, the slope of this part of the curve here is positive. It's not changing at x is 4, and is decreasing when x is less than 4. So when x is less than 4, the slope of the secant on this side is negative. So it'll be the curve is decreasing. Okay, one more. Just again, the problems are made up to help you think and go through what we learned. Remember, we learned all this information on the parabola back in Algebra 2. So everything should be, we're reviewing everything again. Only we're using the average rate of change to review it all. The h of t equals negative 4.8 t squared plus 28 decimal 8 t plus 15 represents the height h in meters of an object in the air at a certain time t in seconds. So we have h and t, height and time. So this is the height of an object that's in the air. So I drew up a little chart here to help you explain this. And again, the height is a function of time. So this is time is the horizontal and the height is the vertical. So find the time when the object is rising, stopped, or falling. Same as this, only I have this equation. So one way to do it is that I can let t equals 0. So if I let t equal 0, so that means I put 0 here, the h of 0. So I put 0 here and 0 here, so that cancels. So when the t is equal to 0, the height is 15. So when t is 0, time is 0, the height is 15. So this object is starting at 15. And notice that we say it's the peak point, so we gotta find the vertex. So this object is coming down. So because that's negative, then this parabola is going to be looping. It's going to be looping. It's going to be the reverse of this one. So instead of going like that, that's a minimum. It'll be doing this. The parabola will be turned over and like that. This parabola is opening up, so that's positive. So this one is going to go opening down like this. Okay, let's see. Now, we want to find vertex. So the vertex of this parabola, another way to find the vertex is do negative b over 2a. That's a fast way to do it. Instead of completing the square on this, we take a negative b. That's a, that's b, that's a, that's b, and that's c. So we go negative 28.8 all over 2 times negative 4.8. So that's negative 28.8 all over negative 9.6. And when you divide that out, I made it up, so you get a 3. So part of the vertex of this parabola, the vertex is that the time is 3. So the vertex is at 3, but we have to find the other value. So now we got to take the t, we're going to put a 3 in here, so the h of 3 equals negative 4.8, 3 squared plus 28.8, 3 plus 15. So by subbing the h of 3, by subbing 3 in the place of t, and when you work all that out, you will get all of that worked out with a calculator will give you approximately 58.2. So this, we have a vertex at 358.2. So 358, again, we're not really concerned exactly 3 is here. So 58.3, let's take a close approximation about right there, give or take. So that means this parabola, this is the vertex, this is the highest point. Because it's a negative, it's coming downward from the vertex. So it leaves here, goes up to this maximum point, and it starts to come down. Now this is coming down here, so where is it going to hit? It's going to hit somewhere over here. Something's coming down, and it's very similar to this, so it's coming down like this. So I just started, and now, how do I know where it's going to come down? Well, it's going to come down and hit here, but we can take other values. We can take other values and plot them. We could take, instead of putting a 3 in, we could put a 4 in, put a 5 in, put a 6 in, and so on. But we got to be careful because it's over here. It's going to hit, if we put a 10 in, probably a 10 would be too much, it'd be way over here. So what we do, we let h of t equal 0. In other words, we let the height equal 0. So we have negative 4.8 t squared plus 28.8 t plus 15 equals 0. So I'm letting the height equal 0. Now, if I let the height equal 0, I have this equation equal to 0. Now, let me draw this. Just watch. If it starts off here and goes up to here, if you would let this line come down here like this, that means this is a negative time. But time can only start at 0. So we can't, yes, I can put a dotted line here, but it won't be here. So when I work this out, I'm going to get a negative number, negative time. But the positive time is over right here. So it's going to hit the ground over here somewhere. So let's see if we can find that time. So let's divide by 4.8. Negative 4.8 into t squared gives me t squared. Negative 4.8 into 28.8 gives me negative 6t. And 15 divided by negative 4.8 gives me a negative 3.125. Now to make this simple, I wanted the a to be 1, which is a good thing to have. So I'm going to say, let's complete the square. So half of negative 6 is negative 3 squared is 9. So let's move that over and add 9 to each side. So I suppose I wanted this to be all by itself, so I moved that over, make it plus. So I added half of negative 6 is negative 3 squared is 9, so I add 9 to both sides. So that gives me t plus 3 squared equals 12.125. So I'm going to have the quote right here now, finish this off. So I have, notice that t plus 3, or sorry, t minus 3, where do I get the plus? T minus 3 is equal to plus minus the root of 12.125. So I'm doing the square root of both sides, but I got a plus minus. So t minus 3 equals plus or minus, and this is going to be approximately, I'm going to say 3.5. So that means that t is equal to 3 plus or minus 3.5. So t is equal to 3 plus 3.5 or 3 minus 3.5. So that means t is equal to 6.5 or, and that's a negative 0.5. So this is the negative 0.5 here, and this one over here is 6.5. So it's roughly, approximately, it's going to come down like this and hit the ground right there, because the height is 0. The height is 0 all along here, so it won't, there's only one answer where this will hit. So this is a 6.5. So what do I do all that for? So it's rising. It's going to rise from 0 less than t less than 3, because the vertex is at this point is 3 comma 58.2, and it's going to stop at 3. So t is equal to 3, and it's falling from here to here because that's a negative slope. So it's falling from 3 less than t less than 6.5. So it's falling from 3 to 6.5. And I thought that's a very interesting problem. And look at the math that I used. All the work that I did on the parabola back in Algebra 2. This is why I keep reviewing, doing questions to help you recall the math that you've learned, which you're going to need in calculus. And so this brings us to the end. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.